webinar from different countries like Philippines, Indonesia, Pakistan, Nepal, Afghanistan, Malaysia, Colombia, Turkey, Nigeria, Algeria, Bangladesh, Cambodia, and Iraq also. Right. This webinar are organized by the inspiration and motivational support of our college principal, Professor Naresh Malik. Today, as you know that you have joined together online through this webinar with major topic on returning soil health and relation to agricultural intensification to meet the growing food demand in relation to enhance the human population. At present, sign of productivity, stagnation, decline of soil fertility, reduced ground and surface water availability, increased extreme climatic events have emerged, and we have to explore, appreciate economic and resource input management options for sustained agricultural productivity. Now I will invite Professor Naresh Kumar Malik, our principal, to address the participant to expert to give of this important theme of this webinar.
Thank you, Dr. G.R. Singh ji. Am I audible? Am I audible, Sudhir
Yes,
ji?
sir. Yes, sir.
Yeah, good morning, Dr. Malik. You're very much audible.
Good morning, madam. निशा जी ठीक हैं?
Yes.
Eminent speakers of this international webinar, Professor Naveen Kalra ji, former head division of agricultural physics and presently resource person trainer at national international level on crop modeling, NRM and climate change, and presently based in Canada. Second eminent resource person or speaker, Dr. Nisha Mehndiratta, advisor scientist G and associate head SPLIC SPLIS, climate change program, Department of Science and Technology, New Delhi. And she has been our student of PhD with Dr. G.R. Singh, organizing secretary of this webinar. Third eminent speaker, Dr. Naresh Kumar Pruthi, our colleague, former head agriculture engineering and soil science, and presently working as adjunct faculty agriculture at Shri Vishwakarma Skill University, Haryana. Dr. H.S. Sirohi, convener of this webinar. Dr. G.R. Singh, organizing secretary of this webinar. And Shivam Rathi, co-organizing secretary of this webinar. Distinguished participants, dear friends, students, ladies and gentlemen. First of all, I welcome you all from depth of my heart on behalf of the college for joining this international webinar. It is a matter of privilege for us that today we have galaxy of distinguished speakers, participants from different parts of the world, different countries, and the credit for this that goes to our colleague, Dr. G.R. Singh and Mr. Shivam Rathi, who have taken pains to organize this webinar. I congratulate them for this mammoth work. Now, as you know, the topic of this webinar, that is meeting the challenges of declining soil productivity and rapidly changing climate for sustainable agricultural production. This is a very relevant and important topic nowadays because today
You
we
are
are
using.
facing
अब आ रही है
आई
हाँ
बस तो
because today we are facing the challenge of declining soil productivity as well as climate change. And this webinar that is for meeting the challenges of declining soil productivity and rapidly changing climate for sustainable agricultural production. So I think this is very relevant topic, and I hope that this webinar will be a success and it will be achieving its goal. I will not take much time. I take this opportunity. I once again felicitate and congratulate as well as welcome our distinguished guests, our speakers and participants for joining this webinar. Thank you very much. Jai Hind, Jai Bharat.
सर यू आर म्यूटेड सर अनम्यूट कर लीजिए अपने आप को गिरिराज सर
Thank you, Doctor. Thank you very much for your important and valuable inputs and views. In this regard, we have invited three eminent speakers to talk on this subject. Our first speaker, Dr. Naveen Kalra, who has dedicated in the field of soil water plant atmosphere intercontinentum, climate change, its variability, impacts, and crop simulation modeling for sustainable agriculture. He was associated with Division of Agriculture Physics, IRI, New Delhi, as a head and principal scientist at the time of retirement. Subsequently, he worked as trainer consultant in Climate Change Network Project of Bangladesh and consultant under Climate Change NARCOM initiative for vulnerability of Indian forecast of Northwest Himalaya at FRI Dehradun. Dr. Kalra has published more than 300 research papers and 12 books in national and international journals. Since 2018, Dr. Kalra shifted to Canada in June 2018 and presently associated with research team of developing machine learning applications in agriculture. List of his work is very extensive, unique and impressive. Today he will speak on farm water management for sustainable agriculture. Now I will invite Dr. Kalla to express his view of this important theme of this seminar. Doctor.
Thank you, Dr. G.R. Singh, actually for arranging this very important webinar, which is attended by more than 500 scientists, not only from India, from other parts of the world. So at present, actually, it's around 12:45 in Canada. So it's a midnight. And actually, I'm just actively waiting for my presentation. And then actually, basically, I'm happy that I'm able to see all the faces, my friends, my colleagues at CCR College. And I'm happy that so many countries are participating in this program. So we all the speaker will try to justify in a way to make it more important so that the participants can learn a bit out of this. So at present, actually, I am working at University of Waterloo and trying to go into newer line of machine learning and artificial intelligence for strawberry crop yield forecasting, which is it at California. So California is the hub of all these fruits and vegetables. And so I'm picking up, developing a new model, strawberry model. And maybe shortly I'll be joining as adjunct professor at University of Waterloo. But at present, I am associating with some of the staff at University of Waterloo, senior professors and directors. So we are trying to work on that aspect, which is a new one. And then actually, basically, it's a new line because computer applications, machine learning, and the agriculture concepts are in a way difficult to digest, in a way to understand the overall system. So that's why I thought that let me go into that because I'm a system modeler. So sometimes people confuse I'm a physiologist. Some people say that I'm a breeder. Some people say I'm a soil scientist. Some people say I'm an agrometallurgist. So my discipline boundaries are broken. So, and then actually I try to integrate all these aspects together. So today actually Dr. Giriraj Singh and Principal Saab, they have asked us to speak on on-farm water management for enhanced agriculture production. That actually, when I joined as a scientist in agriculture physics in 78, I started working on water management, and my PhD was also on water management aspects. And then actually I was working at Water Technology Center, IRA. So we did a lot of work in terms of water production function, watershed management, and many other aspects. So maybe that way actually I thought that let me start placing some of the things. Sometime actually I'll try to define some of the term which I feel because I have more than 40 years of research experience. So I feel that sometime actually most of us, the national scientists, sometimes the conceptually they sometimes are not clear. So I'll try to sometime raise those definitions and points also. So, first actually, as far as I'm talking for sustainability issues, water for agriculture in India especially and South Asia, because I was actually expert for climate change network program where there were about 100 scientists in Bangladesh, senior level and middle level as well as director advisors. So I was actually their trainer as well as I was with them. And in that case, I was associated with them for about 5 years or more than 5 years. But when I shifted to Canada, then my going to Bangladesh was not becoming possible. But I'm online actually working with them. And in last 3 years, we have published around 35 international papers from Bangladesh on climate change aspects. So that way, actually, when I talk of the sustainability issues for water, for agriculture, basically we are talking of India is a intensive agriculture. It's basically poor soil. Organic carbon average is around 0.4, 0.5, 0.6 only. So that way, if I compare organic carbon content of Bangladesh, it's around 0.9 to 1. So the fertility is relatively higher than India. If I talk of Punjab, where the organic carbon is only 0.4 or 0.35, very low. We are getting more yield because of the cooler climates during flowering of wheat, as well as more applications of water and nitrogen and other fertilizers. So that's why we are able to fetch more yield in Punjab. Otherwise, the soil fertility status is almost 0.35 to 0.4. When I talk of Muzaffarnagar soil, your college soils, it's basically dominated by silty loam and somewhere some patches of sandy loam kind of thing. But then actually there the organic carbon content is around 0.6% or so. But basically with intensive agriculture, we are trying to increase the crop intensity. So we are over exploiting the ground and surface waters. Water table in India actually is going down at the rate of around 40 to 60 centimeter per year. It's basically because of the over withdrawal of water, as well as the other kind of activities are going on, industrial activities, population expansion, the residential complexes coming nearby. So that way we are breaking the aquifers, the natural aquifers and all that. So the groundwater recharging is basically may not be taking place. So that way actually what is happening is we are finding a water table decline to the tune of around 40 centimeter. Then decline in water table, surface and groundwater availability, you see amount and quality. Quality is a kind of a concern. Sometimes trace metals, the higher BOD loading we are inputting into the industrial effluents and all that. So that way actually you see that a lot of actually quality deterioration in terms of groundwater is happening. Then actually you see the land degradation because of the sewage, industrial waste and effluents. Intersectoral water use imbalance is there because somewhere the energy for energy purpose, for you see for so many industrial complexes are coming, farmlands are decreasing kind of thing. So that way actually these imbalances are also creating the kind of the water imbalance. Then water availability, when I talk of the climate change, its variability and extreme climatic event is also important. How the rainfall will behave in future climate scenarios, what will be the kind of the changes which will be happening. Then most majority, say significant area of dry land rain-fed agriculture is in our country, in Bangladesh also, in Pakistan also. So in South Asia, when I refer, all these kind of problems are there. So we need to understand about the sustenance of the agriculture production in that. So options for enhanced water use efficiency, that's a kind of a concern. So water nutrient interaction, fertigation, nutrition. Fertigation means when the industrial effluent is there. So effluents are to be diluted with water and the nutrient rich compounds within that industrial waste can be diluted and added as a kind of a irrigation, as well as if we are using the drip irrigation systems within that, the nutrition component going into the drip irrigation, that is fertigation kind of thing. So all those kind of concepts need to be developed. And then the other is design of water productivity functions for the crops. So maybe these are the kind of the issues which actually we are raising, not only here in North American belt, also in Canada, in USA. Also, I'm finding the most of the fruit crops are going with drip systems. They are talking of the fertigation and mulches and all those kind of concepts, where I'm trying to develop the model for those concepts also. So apart from that, the other biotic and abiotic stresses influencing crop growth are also I need to mention. Climatic condition, crops and cropping systems behavior, resource inputs and agronomic management practices, nutrient availability and management, and then insect and pest dynamics, soil characteristics, physical, chemical, and biological aspects, where Dr. Puruthi also will be talking on these aspects. Then it's basically using the need of integrating these factors to assess, manage the agriculture productions. Tools can be simulation models, technical coefficient generators, expert judgment, artificial intelligence. My intention is to introduce artificial intelligence, machine learning in India also from agricultural application. Although people are working in South, I find a lot of people working on artificial intelligence, machine learning in Tamil Nadu and Andhra and other places, but still real agricultural application I'm not finding. So when I am trying to talk about the water, basically as a water scientist, I'm looking only in isolation with water. But crop growth agriculture responses is a integrated result of many biotic and abiotic factors. See, weather is there, soil texture, salinity, sodicity, fertility, land use is there in terms of area under agriculture and other activities. Plant and pests are there, crop varieties and animals system, animal husbandry is also there, production technology in terms of irrigated rain-fed, mechanized organic farming, agronomic inputs, you see, and socioeconomic inputs. So that it's a complex system. If some water scientist is looking only in water, or some climate scientist only looks into climate, then that doesn't make the system true. See, around 35 years or 32 years I devoted in system research. So we could develop a lot of models, and although we were a true field scientist, I had a lot of experience, and during modeling also now I shifted to field applications, going to the fields and all that through remote sensing and many other aspects in a way to integrate. So you see, one thing actually I just want to show some of the abiotic effects, yield of rice in relation to climatic parameters at Ludhiana. You see, when I see the long-term trials from 1985 to 2000, I'm trying to show. When old slide is there, the yield decline, you see I'm finding, and then the potential yield, and then the research station yields and on-farm yields. Throughout, I'm finding the kind of the decline in the yield. And then actually you see in terms of the radiation, if I see the radiation, solar radiation, I'm finding a solar radiation decrease over years. That particular aspect we are finding almost in all parts of the India. So I did some of the kind of the agroclimatic analysis as well as the climatic analysis for different regions in the country. So that kind of scenarios, I already published a lot of papers. And then actually you see that the minimum temperature you were finding is a bit increasing a bit, but that is during winter season, I'm finding the more kind of response. See, monsoonal rain, if like say, whether if I'm talking of the assured irrigation systems, if water availability is in plenty, whether the rainfall is going to influence and all that. So sometimes actually that doesn't happen. You see that if I see the production link with the kind of the drought, the lower peaks are the kind of the drought conditions. So there I'm finding the yields are slightly going down. This type of observation we are finding even in assured irrigated conditions also. So definitely the monsoonal effect is visible, even if you're talking of the assured irrigation systems and all those kind of things. So in West Bengal, Odisha, those kind of, this is actually Dr. Sulochana Gadgil was trying to work on this thing. Actually, she was at Indian Institute of Science, and then we were together that time. So this type of slide actually is basically trying to show the impact of the monsoonal rains anomalies in a way to have the effects. Now see, actually what is happening is that number of rainy days are decreasing. In monsoon time, number of rainy days in India are decreasing. But we are finding the intensity of rainfall is increasing. We have a spell of rainfall, all of a sudden is more. But then the total number of rainy days are going down. So that way actually this kind of scenario is visible. So that already I've shown you that the light to moderate rainfall events, that kind of scenario, you see, I'm finding a kind of declining. Heavy rainfall, you see, are increasing kind of thing. Very heavy rainfall, you see. The kind of the extreme climatic events, that's a kind of a concern more. Rather than the gradual change of climate change is also happening, but to us, the concern is climatic extreme events. Extreme climatic event is a more concern to us in a way to understand the crop responses and all that. Then I come to about the soil health, organic carbon content. If I say unfertilized, if I'm not giving any fertilizer to Pantnagar in the last actually from 70 to 25 years long-term fertility trials, I'm finding decline in organic carbon content. In Palampur, actually, you see the decline is to a lesser extent. Punjab is almost plateauing 0.3% only, very less, although the productivity is very high. So in fertilize also have these kind of trends. Because of the shortage of time, I'm not showing that. So this kind of thing actually I did for almost about 40 locations in the country and about 10 locations in Bangladesh. That type of paper is now coming in an international journal. And then actually terms associated with rainfall. Actually, when I come to water, in that case, the rainfall is very important. Effective rainfall means if I minus out the runoff from the rainfall, normally we say 3 to 5 millimeter of rainfall. We say that we don't count if it is around 3 millimeter, we don't say rainy day event. And then actually runoff, we need to calculate the runoff also. But most of the areas, research areas, we are doing these studies within the confined bonds and all that. So runoff, that way we are not calculating. So the water management, on-field water management in the research experimental fields may not have that kind of meaning if I'm trying to work out on the regional views, those kind of water balance. And then actually you see the intercepted rains. How much canopy is intercepting that of the rainfall? So that actually needs to be worked out also. Okay, if a rainfall event is there, how much intercepted out of the canopy is intercepting the rain, and how much effective rainfall minusing out the runoff and the intercepted one is going to the soil. Then question comes, in India, most of the rainfall in India is received in southwest monsoon. That is actually starts from May in Kerala to around September, it goes. But in Delhi, it comes around 20th June, 24th of June. And then actually that way, actually, one of the chief guests of this seminar, national seminar, is Dr. Akhilesh Gupta. He is expert on these lines. So he actually is basically, he has a lot of expertise. We have to learn from him also those things. But the northeast monsoon is winter season. During winter season, the most of the rainfall comes in basically near Tamil Nadu and all that. In Tamil Nadu, we don't receive southwest monsoon. Southwest monsoon actually is a rain shadow for this particular Tamil Nadu and the kind of the Western Ghats, you can say. And then Western disturbance. This is one term you should know, Western disturbance. In winter, Hindi we say Pala. So Western disturbance brings the rain around 3 to 5 centimeter during winter season, December, January, February. Very important, very good for wheat crop. During wheat, the crown root initiation and tillering stage is going on. That's very useful. That 2 to 3 and 4 centimeter of rainfall is very important. And this western disturbance gives the major rains in Palampur, in Himachal Pradesh, Jammu Kashmir. That is snowfall and all that. But in Indo-Gangetic plains in northwest India, mostly we get the rainfall in terms of 3 to 5 centimeters. Maybe in Palampur, we get very heavy rainfall in this western disturbance. Then one question is about convective rainfall. Convective rainfall is when the places are near equator or very near to equator. In that case, actually the heating is taking place. So the water vaporization is at a very rate. So in that way, actually, all of a sudden, in the afternoon time, the evaporation is taking place, clouds are formed, and the rainfall takes place. So that actually is basically observed near southern belts in India and Sri Lanka, in Singapore and in Jaire. Jaire is the maximum. So in Jaire, you find a rainfall 240 or 250 days, rainy days, convective rains. So that way, these kind of things you should know as a water management scientist. Then actually, you see, we are finding, as I already indicated, you decline in water table in about 80% of the districts in India. to the tune of 30 to 40 centimeter per year. So this is an alarm for us. So we have to be careful in that. Some Punjab farmers, Haryana farmers, they are taking summer rice also, which is somewhat risky because we are over exploiting the water in that case. So, but we cannot stop them. Farmers are not stopping because water is available, they are giving. So there cannot be kind of an administrative control kind of thing. Now I come to components of soil water balance. Very, very important, you see. So soil water content in root zone layers. So basically when you give irrigation, what happens that the water infiltration rate, that means the surface entry of water. Then it recharges the layers to field capacity. The remaining amount of water goes down in the other layer. So that also water keeps on going down till all the layers keeps on filling up to field capacity. Then if you have given more water, that remaining amount of water will then, because of the fringe effect, will go and from bottom to top, then it will start saturating the layers. So then standing water will come. In rice, actually, you're giving water and then you're finding standing water because water is going down, but then actually subsequently what is happening is that it is trying to have that free water, which is ultimately keeping that water in the ponded water, we say. Then the second term comes potential evapotranspiration. Very important. Evapotranspiration is the water requirement of the crops. Evaporation and transpiration. Transpiration is the water loss through the stomates, and then the evaporation loss from the soil surface beneath the crop canopy. So what is the potential evapotranspiration? What is the maximum water loss possible under a given set of condition? That depends on the stage of the crop. That depends upon the kind of the water availability and all that. That is potential is non-limiting supply of water. Then we work out the actual evapotranspiration. We work out the actual evaporation, actual water used from the root zone layers and all that. So that kind of procedure then takes place. Then we work out the actual evaporation losses beneath the canopies. Then remaining, how much drainage is going? What is drainage? Drainage is basic water going out of the root zone is a loss. Ponding means in rice you are giving more water, you are trying to puddle the soil, and so you are decreasing the water infiltration or the permeability in a way permeating downwards in a way that it creates a kind of a ponding and associated losses like say runoff and kind of thing. Then distribution of water applied in various soil layers. Then we try to understand about the water stress effect. If water is available, not available in plenty, it is less than the field capacity water, how the water use will take place, how the growth will be hampered and all that. So this is basically the entire water management scientists. Actually, we talk of the components of soil water balance, which I have hurriedly gone into. But otherwise, actually, there are maybe when I developed this model, it was with the help of more than 100 PhD theses for wheat crop. Then we developed 17 crop models. So much of work came into root activity, root effectiveness, root age, and root growth, root surface area, root length density, evaporation losses, how the evaporation loss is taking place, what is the kind of the, so all those components were detailed worked out by us, but I don't want to go in details here. So Muzaffarnagar, because it's a group of 500 scientists attending, so my intention is to tell you, go into some brief into the kind of the components which are important. So InfoCrop is a model actually which we developed in 2005 to 6. We published in Agriculture Systems, which is very popular, and maybe about more than 100 scientists in the country are using it. In Bangladesh, also some group of scientists are using. In DSET, most of the scientists in Bangladesh, I gave training on use of DSET because it is more user friendly. So in InfoCrop, basically it's a component of integration where the soil water balance is also very important component. So this is this has not come, I think. Yes. So this is the line chart of the infocrop model which we developed about the plant processes. You see, photosynthesis, respiration, then biomass, how much net assimilates are available, how much growth will take place, how much actually, what is the phenology development stage of the crop and all that. And then this is the water balance component, that how much irrigation you are giving, what is the atmospheric evaporative demand, and then how much actually water is required for transpiration, how much evaporation losses will take place, all those components. Then nitrogen balance component, we talk of the this ammonium conversion, nitrogen nitrate conversion, all those kind of things, integrations are there. Then we talk of the greenhouse gases emission also. So this kind of entire detailed program was written by us. Dr. P.K. Agarwal, myself, Subhashan and Patak, actually we developed this model. Now I just want to come to a very important slide for you from water management point of view. If I'm talking for wheat crop, if I talk of the adequate water supply, normally actually we give about 4 irrigation in western UP, in Punjab, Haryana. For wheat crop, we give 3 to 4 irrigation to fetch about 95% of the yield, which I can get the maximum. But then actually how much fertilizer should be applied in a way, because if I apply more water, then nitrogen should not be a limitation, nitrogen losses also should not be there, kind of thing. So I am finding out the kind of the dose, you see. I can afford a dose of around 150 to 180. In Punjab, I'm finding 180 kg of nitrogen is being applied now to get a yield of around 5 to 6 tons per acre. If I'm having only 2 irrigations, moderate water supply at crown root initiation stage and flowering stage, in that case, I need to apply about 100 kg only. Thereafter, I start finding declining yield, because over-exploitation, overgrowth is taking place, and the national availability then becomes a concern at flowering. If only one irrigation is there with me, that is at crown root initiation stage, then I need to apply about 50 kg or 60 kg only. In that case, if the water table is high, then it can go about to 80 kg or so. If the water table is around 1 meter to 1.5 meter, then it can, because of it can also. If it is a kind of case, I need to apply, you see, there is no effect of any fertilizer. So that's the kind of thing. So I have to note down that if water availability is a concern to me, then actually I need to also design the fertilizer dosing accordingly. NPK, zinc, boron, sulfur, everything, you see. Because you see that I took voluntary retirement in 2008. I joined Tata Chemicals, where I started working on multi-nutrient interaction. I developed model for customized fertilizer design and all those things. So I have complete now knowledge, which I was not having that time when I was at IRA, but I know I could learn many things out of that. So I just come to some of the concerns of rice wheat cropping system, which is the major water consuming crop. Decline in rice wheat productivity I'm finding. Reduction of partial factor productivity of NPK I'm finding. Very important. Earlier, per kg of nitrogen application was giving a certain yield. Now per kg of nitrogen application is reduced response, because the soil health is going down. Contamination of groundwater, delay in sowing of wheat is a concern, because after harvest of rice crop, the sowing of wheat is to be delayed. So that's why we started coming to zero tillage, minimum tillage and all that. A lot of work was done in CIMET and IRI. And then actually this national trials were done. And then now actually we are trying to develop that model also in a way to tillage dynamic space model for zero tillage, minimum tillage. Then introduction to newer insect and pest in rice feed systems are also emerging. Then because of the zero tillage, minimum tillage, those kind of dynamics are changing. Then reduce soil nutrients availability, primary, secondary, and micronutrients, and frequent occurrence of extreme climatic events. And remedies are choice of crops and cropping systems. Sometimes we say start taking maize, but farmers don't agree. Water management is a concern. You go for direct seeding or go for kind of alternate wetting, drying kind of options for rice. Then integrated pest management is also comes a concern. then adoption of suitable tillage methods. These are the kind of the concerns where the water compartment is very big. Then I come to fertigation and nutrition. You see, when actually industrialization is there, industrial solid waste, effluents are released. Sometimes those effluents are pollutants also, but they are rich in nutrient sources also. Like say, if I talk of the sugar and distillery effluents, they're rich in potassium. They're rich in nitrogen also. If I can utilize that, Doctor, you see, in that case, actually, you see that this kind of experience, Dr. Pruthi actually is having good experience. He was associated with some industries there. So I remember that time the discussion was going on. So that fertigation is important in a way that how that effluent can be utilized. If effluent is creating a kind of a pollution in a limited area, we have to expand its application. So if we start giving that fertigation in terms of dilution of that level of that sugar or distillery effluent in a way that then actually we can get the benefit of that fertilizer and all that. So that with this fertigation and nutrition also comes in the concept of drip irrigation systems, where actually we have to find out how the water soluble fertilizers are to be mixed up. So that's the story of water soluble fertilizers, how that through drip system is to be worked out. A lot of work has to be done in North America also. We are developing those kind of now actually at present, actually after strawberry, my turn is now on tomato crop. I'm trying to now develop on these aspects. So, and then actually on-farm water management, the cropping system based irrigation schedules, not over exploitation of irrigation. If you have canal irrigation water and if you have electricity subsidies are there, you are over exploiting water application by taking more electricity and all that. Drip systems, green technology, fertigation, already I told you. Then there is a kind of product called hydrogel. Hydrogel is a kind of a product where actually it can retain water. A volume of the hydrogel is 750 times that of the volume. So that way, hydrogel applications in rainfed systems kind of thing is, how much time is there, Dr. Giriraj? So how much time I should speak till now? About 10 minutes or so?
Yeah, okay, sir. No problem.
Okay. So then actually the poor quality water management, saline, sodic waters,
sir.
effluents, industrial waste, where actually you see that.
बस ये निशा जी का खत्म होने के बाद निशा जी बता देंगे कितनी देर बोलेंगे.
अच्छा, तो अभी मेरे कितना टाइम है? अभी 10 मिनट के करीब है कि 5 मिनट?
10 minutes. 10 minutes, sir.
Okay. I will cover up. I'm trying to go fast, but then I thought that maybe now see that basically I now come to the water use efficiency. What is water use efficiency? Water use efficiency is basically I can express in terms of the yield, I can express in terms of the biomass. So water use efficiency is basically total biomass per hectare in tons per hectare divided by total evapotranspiration during the entire season of the crop. That is total evapotranspiration. If evapotranspiration is 40 centimeters in wheat, for example, I get 4 tons of yield. So 4,000 kg divided by 40 centimeter means 100 kg per centimeter of water use. So 100 centimeter per centimeter, 100 kg of wheat yield I am finding per centimeter of water use. If I talk of the water use efficiency in terms of the total biomass, I get 14 tons. If I am getting 4 tons of yield, grain yield of wheat, I get around 14 kg of, because of the harvest index is around 35%. So in that case, I get around 14 tons per hectare divided by 40. So 14,000 divided by 40 means the efficiency comes 300 to 350 kg biomass per centimeter of water use. So precious water. In rice, it is very, very high. This much centimeter of water in per kg is really, really costly, very, very precious. So you see, I try to work out about the water production functions. That means water use in terms of the yield of wheat. It goes on. It's a kind of not a straight line curve. It's a kind of a plateauing curve. It's a combination of so many experiments. About 400 trials are there. So in 400 trials conducted in different parts of the country. So this kind of work was done by one of my students, actually. And then actually Rajesh Chattopadhyay, so he actually worked on this aspect. And then we worked on water production functions. So in that case, so many crops we worked out: wheat, rice, mustard, maize, and then the gram. So all those kind of things actually we did for the entire country, you see. And then actually see, then one term comes applied water use efficiency. Applied water use efficiency means how much water I am applying. Rainfall plus irrigation water, which I am applying. So yield, grain yield divided by applied water is the applied water use efficiency. In rice, it is very poor. So that way, actually, we are concerned. Should we take more rice, or should we bring on some kind of alternative for rice in case of maize? Kind of thing happening in now Bangladesh. It's happening now. Somewhere we are trying to change. Then the other term comes conjunctive water use. This is very, very important. Conjunctive water use efficiency means conjunctive water use poor quality water. That means effluent water kind of thing in conjunction with some good water. I am adding 20% of distillery effluent plus 80% of good water. Then I am trying to give irrigation and finding out the efficiency. So that is conjunctive water use. Another one is consumptive water use. Consumptive water use is evapotranspiration, how much has happened, plus drainage, how much water loss has taken from the root zone. In case of rice, we talk more because we apply more water. So if the evapotranspiration is around 60 centimeter of water, 50 to 60 centimeter I get with a yield of around 6 tons. So in that case, actually in rice, I say consumptive water use wise, it will be 60 centimeter plus about 30 centimeter more. So 90 centimeter will be more. So much of great loss. Then comes the water production functions. So this type of work curve which I am showing now, this is so much of dependence. This is the total water use in the entire season. But I have worked out the water use in up to crown root, from crown root to tillering to flowering to milk stage to harvest. And then actually I have tried to drive those kind of functions in a way, the seasonal, the dated production functions kind of thing. So much of, and this particular scope is there in machine learning now. So now I want to develop these kind of functions in machine learning and neural network systems and all that. So that's also there. I thought that I wanted to raise these type of terms to the group in a way that at least they all must be knowing, but sometimes actually confusion is there in conjunctive, consumptive, water production functions. So I thought that let me address those things. So this I am trying to show for rice, for mustard kind of things. So I will not go into details. Then actually irrigation management for sustenance, textural base. If I talk of sandy soils, in sandy soils, I have to talk of compaction, roller, heavy rollers in a way to decrease the permeability. Then I am talking of you give less amount of water for irrigation, frequent irrigation, but less amount. So that is the major thing in sandy soils. In silty clay loam soils, you already know your soils are there. Muzaffarnagar soil, rice belts is there. There actually find that the kind of the total loss rate is around 4 centimeter per day, 4 to 5 centimeter. When we do the puddling, it comes to around 1 centimeter per day or 1.5 centimeter per day. So that way, but then the puddling is also restoring with the growth. So that the losses also start increasing. So we have to manage the soils in a way that how we have to, so alternate wetting drying. So in Muzaffarnagar or in Punjab or Haryana soils, after 2 days after disappearance of water, again we start giving water. We are able to save the water. In clay soil, very important, you see, the loss is less than 1 centimeter per day. So if you give more irrigation, the water logging will be there. And then if the drying is there, the cracking will be there. So most kind of concerns, I don't want to go in detail, but then I thought that in clay soil, you have to be very alert in a way to do the kind of the irrigation management in a way that you're kind of, then we start talking of the ridge and furrow methods, bed planting and all that. So that actually in US and Canada also, strawberry crop sometimes is water sensitive at some stages. So they are going for bed plants only. So bed planting, mulching, because sometimes the temperature goes down to below zero. So in that case, actually you see that we have to be, then rain-fed and dryland agriculture is one of the prime area where you have to talk about the kind of the crops, choices, the water management practices. One actually key point I want to tell you is if rain-fed is and dry land is there, water is a problem. In that case, your seedling emergence, germination, and crop stand is the criteria. You have to only have that much amount of water so that the germination takes place and the stand establish, so that you are able to fetch about 1 ton or less than 1 ton. Watershed management, I need not go into that, but then watershed is basically a particular area of under observation where the water, uh, through the water losses, through rain runoff and all that, they are coming down at a given point, and then they are monitoring that how much water is stored, how much irrigation, lift irrigation can be given, how much nutrient loss has taken place from that. So how the management has to be done. So then actually basically comes the soil moisture retention, release and transmission characteristics, which are entirely different from textural base and all that. So we have to understand. Maybe I think time is not there. Otherwise, my PhD was on all these aspects, and we did a lot of work actually in pedo transfer functions and all that. So in Bangladesh, I published one paper. You can visit our research gate, and in that case, I have plotted for the entire Bangladesh these districts. We have plotted these kind of curves, and then pedo transfer functions in a way that we are talking about some of the basic soil moisture constants like say bulk density, field capacity, wilting point, available soil water, hydraulic conductivity, infiltration rate, and then these kind of components are required for water management point of view, but they are not available from soil survey records. So that way actually we developed these kind of functions for the entire country, for Bangladesh also. In DSET actually models, actually we use these, we modified those things for all the districts as well as for of India and Bangladesh, as well as for Infocrop also we have developed these things. So these kind of pedo transfer functions are must not only for water constants, but also for nutrients availability and all that. So these kind of pedo transfer functions basically thought that. So this is, you see, my last slide, which I say basically, I'm talking on a regional scale. I'm a modeler, detailed dynamic modeler, but now I'm a simple model developer. I believe in very simple model development. With one-page model, I want to develop the strawberry crop. I developed for tea and coconut in Sri Lanka. Now in forest, actually for Pinus roxburghi, Dr. Manoj Kumar, one of my PhD student, actually his work on this particular Pinus roxburghi. So this 1 year as an expert in Forest Research Institute, I developed that. But then basically all these kind of, in India, I say that a lot of research manpower is there, a lot of bases are there, soil test value, millions of soil test values are there. But that way we don't find any operational program for soil test based irrigation management or fertilizer management kind of thing. So that way, that's not operational. So I feel that basically the online agro advisory or online management for farmers has to be there, where pre-sown operational and post-harvest advisories outlining optimal production zones, planting crop cycles with weather and markets. Stakeholders can be farmers, can be agri-clinics, researchers, NGOs, planners, and agro-industries. So basically, it's a vast window, but then 500 scientists attending this online, young people, we are old people, 65 plus, but still actually we are trying to now, maybe 2 years, 3 years we are active, and then subsequently we will vanish away. So the young force like Giriraj and these people, they have to take up now. And Principal Saab is there, he will as always encourages you. So I feel that thanks for the opportunity which you have given to me in a way to speak on this aspect, in a way to express. But then I end on this point. And if any question, you are always welcome, sir. So, Dr. Giriraj.
Okay, sir. Thank you, Doctor. Thank you, Dr. Naveen Kalra, for sharing your very informative speech and thoughts with us. I would like to express my special thanks to you for giving us your valuable time from Canada, as it is not the regular working time. Your dedication really inspiring us. Thank you. Thank you again, Doctor. Thank you.
Thank you. Thank you. Thanks.
Now I would like to introduce our second speaker, Dr. N.K. Pruthi, who has been my mentor and vast experience and renewed in the field of evaluating soil environment and crop growth. Dr. Pruthi has vast experience in the field of agricultural chemistry, soil fertility, and soil health for identifying option for enhanced agri production and substances. He had 42 years of research and teaching level at Meerut University and published numerous research papers in national and international journals. I am sure the participant will appreciate and gain extensively throughout his talk on soil health initiatives.
Well, Dr.
Now I
Girasing.
will invite.
Hello. I am interrupting Dr. Girasing. I think Dr. Nisha is waiting for her lecture. So can you ask?
No.
Can you
After
ask?
that.
Okay.
Okay. You start. Now I will invite to Naresh Pruthi to express his views.
Thank you, Dr. Girasing, and all the organizers of the Chotram College, Muzaffarnagar, where I spent more than 42 years there. And I am visualizing Dr. Randar Suroi also, my respected principal, and Dr. Kalra, Dr. Mandiratta, and co-organizing Shivam is also there on the screen. Thank you for inviting me for a lecture. Though we are not very well concerned with the research, but theoretical aspects of the topic is very well known to me. So as Dr. Kalra was saying that a lot of work has been done by us, I think we can say that very less work we have done in this field and as far as the research is concerned. So when I will be getting any problem, so I will request Dr. Kalra to associate me. Uh, Thanks once again. So before starting, I would like to share the slides. So my topic as you see, soil health assessment and its management for sustainable agriculture production. So when we talk of about the sustainable issues, so first issue, I think it should be declining and deterioration of natural resources. So declining and deterioration of natural resources applies as the soil, water, and our environmental degradation aspects and other. So natural resources we have to conserve. Say for example, overexploitation of surface and groundwater, as Dr. Kalra raised on this topic. And
Puruthi sir, sorry to intervene. आपका वो दिख नहीं रहा, that presentation. It is not seen by people.
okay,
Is it a
I'll try.
PowerPoint?
Udhay ji,
अगर PowerPoint है तो please share with everyone. If it is
Yes,
an
yes.
address, it is fine.
No, it is in PowerPoint.
Yeah, I could feel that. So you have to go for
Okay.
share screen option.
Okay.
Share screen. And just go to the desktop and click that share button. Yes, yes.
Now is
Yes.
it clear?
Yeah, it's coming now.
Okay. So now is it visible? Hello?
Yes, it's visible. It's visible. May please start. Continue with your talk.
Okay. So soil degradation and soil health issues, nutrient mining and multiple nutrient deficiencies, decrease in soil organic carbon, over exploitation of surface and groundwater resources, environmental issues, say for example, climate variability, change, extreme events, solid waste effluents, pest buildup due to monotonous cropping systems, decreasing biodiversity, shrinking farm profitability, declining factor productivity, and nutritional insecurity. These all are the sustainability issues come across during the cropping. So, as my topic is related to soil health management and sustainable agriculture. So in this chapter, in this topic, we have to discuss about the soil health issues and its assessment, and how can we forecast or how can we make module on these with various parameters or characters. So this I have to discuss. Minimum characters required for the agriculture development is physical, chemical, and biological indicators. These are required indicators which we have to observe during the course of soil health characterization and soil health assessment. So integration of these indicators for overall soil health to make soil health index. So these parameters we have to take into consideration. Use of these indicators in soil health aspects, say for example, soil capability classification, sustainable agri-management strategies, crop choices and resource management options, nutrient management, and agronomic and input management. So some business model like soil health card and related agro advisory services,
Yes, yes.
these have to be considered. So next is soil ecosystem, which can be managed. So there are some intrinsic characters of the soil which we cannot manipulate easily, but some characters for some attributes we can manage easily. So intrinsic characteristics, say for example, soil texture, available hard pan, or compaction of the soil is there. So these are the characters which we cannot manage easily. So the soil ecosystem which we can manage to provide nutrients for plant growth, absorb and hold rainwater for use during drier periods, filter and buffer potential pollutants from leaving our fields, serve as a firm foundation for agricultural activities, provide habitat for soil microbes to flourish and diversify to keep the ecosystem running smoothly. So these parameters we can manipulate. So as far as the soil health assessment uh, is concerned, as we all know that UN Sustainable Development Goals related to food, water, climate, health and biodiversity, these all are directly related to soil ecosystem. So which account for immediate benefits that human societies derive from soil. So because these issues are directly related for the benefit of the human beings, so these issues we have to take for poverty alleviation also, because when we manage our soil for a higher production level, so we can easily uh, be able to sustain or able to feed our uh, population increasing uh, demand. So soil plays a key role for functioning of terrestrial ecosystem. This is essential for human society, not only because they form a balance to produce food, but it provides a foundation for other essential ecosystem services. So the soil health concept require development of a holistic index for reliable and quantitative assessment of soil well-being related to the effects of different soil management practices and land uses. Health of the soil gives us clean air, water, good crops and forest, productive and grazing land, diverse wildlife and beautiful landscape. So if this healthy soil is there, so all these things can manage very well. So this is these are the soil health issues which we have to take taken into considerations. Soil health also referred to as soil quality, which is defined as a continuous capacity of soil to function as a vital living ecosystem teeming with billions of bacteria and fungi and other microbes that are the foundation of an elegant symbiotic ecosystem. So sustain plants, animals, and humans, provide the necessities of life, food, shelter, and water, perform functions required to produce food and fiber. So evaluation of these, as I said, evaluation of the soil intrinsic potential should be related to inherent soil properties. So texture, mineralogy, soil depth, climate, since all that can be affected by soil management is only relevant for reaching this potential. So these are very tedious to manage, these all parameters. While soil health, also referred to as soil quality, is defined as the continuous capacity of soil to function as a vital living ecosystem. So I think this line is again repeating. Dynamic soil quality is how soil changes depending on how it is managed. So soil quality we can manage by altering and by applying some. So management choices affect the amount of soil organic matter, soil structure, soil depth and water and nutrient holding capacity. Soils respond differently to management depending on the inherent properties of the soil. So inherent soil quality is a soil's natural ability to function. For example, sandy soil drains faster than clay soil. Deep soil has more room for roots than soils with bedrock near the surface. These characteristics do not change easily. As I told earlier, that hard pan if developed in the soil, so it will hamper the penetration of the roots easily, and so the crop may affect. So some features which we have to consider: soil does all this by performing 5 essential functions. As you know, regulating water, because when we receive water from rain, snowmelt and irrigation water, it directly goes into the soil and it dissolves solutes flow over the land or into and through the soil. So sustaining plant and animal life, the diversity and productivity of living things depend on soil. Because a healthy soil which sustains the diversity and the living things, it may be a productive soil. So filtering and buffering potential pollutants. This is the characteristic of the soil, that it acts to filter. The minerals and microbes in the soil are responsible for filtering, buffering, degrading, immobilizing, and detoxifying organic and inorganic materials, including industrial and municipal byproducts and atmospheric deposits. So these microorganisms and uh, soil as a filtering agent both combine and take this process. So another function of the soil is cycling nutrients. Various cycles of the nutrients is performed by the soil, performed in the soil. That is, carbon, nitrogen, phosphorus, and many other nutrients are stored, transformed, and cycled. So these all activity uh, provide some nutrition, and various transformations followed in the soil give different types of product in the soil. Physical stability and support. This is the main feature of the soil. As we know that plant roots stabilize in the soil and it provide physical stability and support. So to assess the soil, we have to focus on the matching of the specific soil requirement of land use with the properties of the soil. So suppose for a particular crop we have to assess a soil. So different types of parameters which will I discuss later on. We have to consider according to the models we have seen as in Colorado model, Ohio model. So these are parameters we have to discuss for modulation. So most of soil assessment have been made for agricultural land use and cropping systems, but the same principle could be applied for other application also. So soil quality is a measure of the capacity of a soil to perform necessary functions. As we know, soil functions include it provides nutrients, water to plants, filtering and cleaning water, regulating temperatures, recycling and storing nutrients, and providing habitat for organisms. These are the all parameters we have to consider when we talk about the assessment of the soil quality. So these are the some parameters to assess soil quality. These attributes have to be considered: soil depth, soil texture, soil structure, surface crust, soil color, soil life, and roots. So different approaches of soil quality assessment we have to consider. These are, say for example, the kernel approach. They they have considered three parameters: physical, biological, and chemicals. So in physical, they have included aggregate stability. They have to determine the aggregate stability, available water capacity, surface hardness, subsurface hardness as the physical attributes. And in biological attributes, organic matter, active carbon, potentially mineralizable nitrogen, root pathogen pressure, good and bad nematodes. So in chemical, soil pH, macronutrients, micronutrients, and toxic elements. These all are characteristics we have to measure to make a model to forecast yield, nutritional requirement, and to assess the fertility status. Suppose we are considering the Illinois Soil Quality Initiative. So soil quality, they are considering nutrient supply. Yeah, they have taken into consideration the content of available nitrogen, available phosphorus, available potash, soil organic carbon, pH, and the soil water relations by determining the residue, porosity, aggregate stability, soil organic carbon, and micropores available in the soil. Subrouting characteristics also they have considered: soil organic carbon, bulk density, penetration, resistance, and pH. So these all are based on the Illinois model. And Ohio Soil Health Card, they have considered soil tilth, structure, crusting compaction, soil life, in the form of earthworm, smell, residue, composition, decomposition, and soil, air, and water by determining drainage also. So these are the some scoring criteria for chemical rating. So suppose we are seeing the organic carbon here in pH, available potash, and available phosphorus. So these are the score which they have given for making a model, crop model. So for a particular crop, these are the scores we have to decide according to their determination in the soil. So this is the criteria score for chemical rating. these 4 parameters: organic carbon, pH, available potash, and available phosphorus, they are considered. So scoring criteria for physical rating: bulk density, available water, and infiltration rate. So these are the scoring criteria for physical parameters. So available nitrogen as related to organic carbon content. This is also having a criteria to assess or to make a model, and microbial activity as influenced by electrical conductivity. This is the relation between microorganism and the electrical conductivity present in the soil. These are the values of electrical conductivity showing the microbial activity factor. So this is the criteria we have to consider for making the model, crop model. So EC sensitivity for various crops here is given. Very sensitive, moderately tolerant, moderately sensitive, and tolerant crops. The list of the crops we have shown here. So possible application window for soil health services is nutrient management on the basis of availability of nutrients in soil, pH, EC, crop type, soil texture, bulk density, soil mechanical independence for root growth, adaptive tillage and residue management, prevailing weather. These all are parameters for nutrient management we have to consider. And for water management on the basis of soil texture, bulk density, soil mechanical impedance, soil available water, crop type, nutrient input, and prevailing weather conditions. So tillage needs on the basis of crop type, surface roughness and moisture conditions, soil density, soil mechanical impedance, extent of reduction, delay of sowing of wheat, extent of water logging as a function of time. These all are the parameters we have to consider for tillage need, and the insect and pest extent and control options on the basis of crop type, soil moisture and irrigation schedule, nutrients input, weather condition, mainly rainfall, humidity and temperature. So these are, thank you. These are the some characteristics which we can consider for soil health assessment and making the model for a crop, particular crop. These are some models I have taken from the literature. We can consider these and we can put the attributes accordingly to make these models. So I think Dr. Kalra is seeing patiently in spite of the night time. He is with us, so he can share some aspects in my, and he can give some inputs in my this lecture. Dr. Kalra, please have any input.
I think Dr. Pruthi has really given a very nice presentation, in a way raising the aspects of integrating physical, chemical, and biological aspects to develop a soil health index. So, and then actually the kind of the attributes, so many attributes are there in a way, and then actually how to club them together in a way to decide. So, but still, I think Dr. Pruthi has a good experience. I know him since 15, 20 years back when we started coming to Muzaffarnagar, and nice person, nice scientist, nice teacher. And I appreciate your presentation. It's really nice, and we have to go long way. Although you are retired, I am also retired, but still we have to go till we survive. We have to keep on doing research. That's my mission. So I think you can deliver it in industrial waste utilization. You have good experience in micronutrient interaction and all that. So maybe I think it was a nice presentation, and I appreciate your efforts, and you raised these issues, and really I appreciate you. Thank you very much.
Thank you. Thank you.
Okay. Thank you, Dr. Saab, Dr. Pruthiji, for providing us your time and sharing your valuable thoughts with us. Now, I would like to introduce our third speaker, Dr. Nisha Mandiratta, presently holding a prestigious position of advisor of Ministry of Science and Technology, Government of India, New Delhi, for climate change network mission of our country. Dr. Nisha Mandiratta is also an eminent scientist having experience in the field of agriculture physics, agrometeorology and crop yield production. She has worked vast as a scientist in agriculture application remote sensing technique. She has wide experience in natural resource management, medium range weather forecast for agro advisory services, climate change and climate variability in relation to agriculture and other related sectors. Proudly, I can say that she was a very bright research scholar from our college who completed her PhD program under my guidance. Dr. Nisha has published a lot of research papers and, and country reports on climate change, control initiatives for India, and today she will speak the same topic to the audience. Now I will invite Dr. Nisha to express her views.
Respected Professor Malik, Professor Naveen Kalra, Dr. Puruthi, Dr. Singh, Dr. Sirohi, all dear friends all across the world, and participants from various institutions of the country. Before I start, I would like to say, Dr. Giriraj Singh, that please don't give such a this kind of introduction for me in front of illuminaries like Dr. Kalra. You all, I was so lucky to be a part of your team, and you both have guided me so immensely during the process of my PhD. And Dr. Malik had been a great support as a principal of the college. I am really very thankful to all of you, especially to Dr. Kalra, who has guided me so immensely during the process of my PhD. And Dr. Malik, hello, ma'am. Seeing me now? Hello.
Yes, ma'am.
Yeah, there was a problem, technical clinch here. That's why I got myself connected in two systems. So I hope you're able to hear me. Hello. Am I audible?
Yes,
Hello.
you are audible. You can continue.
Yes, you are audible.
Okay. Yeah. There is some problem in Zoom platform. I informed Dr. Giriraj yesterday. So anyhow, if there is some problem in between, in lack of connection, I feel sorry for that. But I have got connected in two systems right now. I hope there is no confusion. So I was just saying that in such an important webinar, which is on meeting the challenges of declining soil productivity and rapidly changing climate for sustainable agriculture production. My previous eminent speakers, Dr. Kalra, Dr. Prothi, they have given a very important, they have covered important aspects on water management and soil health assessment for agricultural production. And with their immense knowledge and experience in this field for more than 30 years, they have given a very good capture of the soil model, like modeling approach, especially Dr. Kalra in Infocrop. He has been a great resource person. Now he's working with different countries also as an eminent researcher. And Dr. Pruthi also has been a soil expert. So being me as a person working with the climate change program of Department of Science and Technology, I would like to give a broad idea about the climate change, its impact on agriculture. And I have been associated with the IPCC. I hope the international researchers from their country also, they might be participating in climate change dialogues conducted by UNFCCC, United Nations Framework of Climate Change, which is being held every year. This year, of course, it was not there. So I have been participating from Government of India's representative uh, in this international forum for climate change, and agriculture is again one of the important aspects being discussed there. So broadly, I will just mention about all those. So let me again start sharing my presentation. So I have to try it again. I hope I am successful in doing it. Just yeah, my screen is there. Hello.
Yes, ma'am. It
Yeah.
is visible.
So I can start with my presentation, no? Yeah.
Yes, yes.
There is no voice problem.
Your voice is coming.
Okay. So before I start, I would like to just mention that we will be joined shortly by Dr. Akhilesh Gupta also, who was former secretary of UGC and also heading the climate change program of Department of Science and Technology, along with other programs. So we requested him, and he will also give after my talk a broad idea about the overall gamut of issues. So I will be broadly covering the agriculture scenario all across the world. Then what are the climate change issues and its impact, especially on agriculture? What are the broad IPCC projections? IPCC is International Panel on Climate Change, which I mentioned that I have been representing UNFCC from Government of India side. So I would like all the youngsters to know that what are the projections for this century and how they can contribute through their research activities for our country and also in their country, respective countries. And broad issues and concerns, what kind of solutions are being thought of, and then what are the national initiatives in agriculture sector being planned in our country. So broadly, my presentation will be on these aspects. So as like all of us know, all across the world, when we talk about developing countries, 60% of our population is mainly dependent on agriculture, and it contributes to around 30% to our gross domestic product. Countries which are most vulnerable to climate change in this region are Afghanistan, Bangladesh, Cambodia, India, Laos, Myanmar, and Nepal. And when we see that particularly which countries are very much vulnerable, so I will categorize, or the studies are categorizing Afghanistan, Bangladesh, Nepal, and our country. So we all are very much vulnerable to the adverse impact of climate change. So I will come to that. What are the adverse effects later on? Then what kind of impact on climate change on the agricultural sector specific to the Asian Pacific region? I mean, I hope some of the participants might be interested in knowing this aspect. So here, friends, I would like to say that study says decrease in crop yields could threaten the food security of 1.6 billion people in Asia. And here there are two terms which often we speak: crop production and productivity decline. So there is a decline in crop production, which is projected to be, I am talking in reverse order, more in wheat, followed by rice and maize, when we compare it to the production level at 2000 years or so. And similarly, there is a decline projection for crop yield, and the reverse, like again, I'm saying in that mode, which is more for rice, followed by soybean, wheat, and then maize. So these are the broad projections when we talk about crop productivity and crop yield levels for the major crop in Asian Pacific region. Now coming to India. As you all know, wheat, rice, and maize, these are our main food crops. And when we talk about cash crops with which our farmers are getting their like benefits, these are sugarcane, cotton, and tobacco. So in India, these are the major main crops, and around 198.4 million hectare of our area is under cultivation. And here, 63% is mainly rain-fed, while 37% are irrigated. So here, all of you know, but I want to give you a current statistic that still we are largely dependent on monsoon. That is what all of you should know. Here, when we talk about the contribution of agriculture towards employment, it's around 49%, and 16.5 of our GDP is dependent on agriculture. Rather, when we talk about rural India, 70% of the livelihood is dependent on agriculture still. But we find mostly the farmers are belonging to small and marginal categories. So that is a issue of concern. When we are talking about agriculture productivity or soil productivity, we have to look towards the requirement of small and marginal farmers in our approaches. All researchers should think from their perspective while drawing any strategy or any mechanism. So this information is from Department of Agriculture. This is the latest statistic which I am showing to you. Now, the scenario of crop agriculture productivity in India, because I thought we are talking about in this important seminar about soil productivity and like other aspects which are related to the agriculture production. So here I want to give you an overall idea that agriculture productivity depends on several factors which are integrated in a manner. So these are broadly the availability and quality of agricultural inputs such as land, water, seeds, fertilizers, access to agriculture credit and crop assurances. These are certain other things which are covered in different fields, but I am just taking it as an opportunity to give you as an introductory thing assurance of numerative prices for agricultural produce, storage and marketing infrastructure. All these things are put together. They will lead to a holistic approach going towards agriculture productivity of any region. So nowadays we are talking about the micro level management also. So all these things need to be seen in totality by a researcher and also a decision maker. So because I belong to the organization which is providing inputs to the decision maker. That's why I thought of giving the overall idea to all of you. Now, as I'm very sure all of you know that our production has increased multifold from the era of green evolution to current age. From 51 million tons, we have risen to 291 or around 292 million tons. So it is a thing to be really feel proud. But still, despite having high level of production, India is having very lower like productivity when we compare to other developing countries such as China, Brazil, and USA. Here, this is only to give you a glimpse. I will not go into detail of it. So you can see paddy, wheat, other cereals, and pulses. And the comparison shows in these four countries, which I mentioned right now. Blue represent India. So you can see still we have a long way to move ahead to meet the challenge and to come closer to these other large producing countries. So this is an overall idea about the agriculture scenario and in the developing countries, and where are we now. As my talk talks about issues and challenges, rather this topic was suggested to me by Dr. Kalra. I am thankful to him for giving this topic to me, because he might have thought that overall issues I will cover in this seminar. So I am starting with the issues. That is what I could think of. The issues and factors which are leading to the low agricultural productivity. Now, that is what we have to look into. So broadly, what I could capture, these are the issues in Indian agriculture. Marginal and small land holdings, already I mentioned about it. Unavailability of water. This is one of the issue of great concern. As already I said, that most of our agriculture is rain-fed, it's water dependent, and 80% of the surface water is being utilized alone for agriculture, and inefficient irrigation systems, and again the overutilization of groundwater. So there are many other factors which are really contributing to the low agricultural productivity. And Dr. Kalra had mentioned in his talk about the water management aspect as well. So this is one issue of worry, and I'm so happy that extraordinary work is being done by various groups, including him, in this sector. Then degrading quality of soil. This is another important issue, uh, which again Dr. Puruthi has covered most of the issues so nicely in his presentation. And here it says that about 5.3 billion tons of soil gets eroded annually, of about 16.4 like tons per hectare. So there are many more figures which was discussed by him in his presentation. So broad, these two topics are covered in today's webinar. Then land degradation, imbalance in the use of fertilizers, which of course Dr. Kalra covered in his InfoCrop model. But here I would like to say that earlier recommended doses of fertilizers were 4:2:1. But the ratio in India is currently has increased like anything, which is leading to the loss of fertility in the soil over a period of time. This is again an issue of great concern. And especially I want to urge to the students of Muzaffarnagar University that being a student of agriculture chemistry, and I know Dr. Giriraj was always so concerned about agriculture chemistry. He told me that, madam, please cover that soil related aspect in your talk. So I am just again emphasizing on this, that imbalance in the use of fertilizers and again the soil related aspect need to be taken up by the students of Chaudhary Chuturam College. And I would also love to be involved in some way or the other if required in this study. Yeah. Next is the agricultural mechanization and then climate change impacts. So these are broadly issues which are again affecting our productivity. Now coming to my next slide. I don't know, it's not moving. Yeah. So climate change. Now I'm coming to the second aspect, second section of my presentation. Impacts of climate change. Again, I am not going to cover all that because it requires a detailed lecture altogether about the climate change and its impact. But this flow chart will tell you broadly about the climate change process. And I'm very sure everyone might be knowing by now that greenhouse gases, the increase in the concentration of greenhouse gases in the atmosphere, and now added by aerosols. We are finding smogs and fog everywhere all across India, and even especially the northern part of country. So aerosols are the main culprit. Greenhouse gases along with aerosols, they have got a very increased concentration since the pre-industrial era, and they are leading to the climate change processes, which is now evident through the increase in temperature, precipitation change, sea level rise, and many extreme weather events are happening all across the world. Now, in what way these are affecting? These are affecting our life. So the climate change processes, they are having a great adverse impact on the ecosystems, especially which is comprising of our water resources, land resources, bioresources, food security, human health, socio-economy aspect, and many more are there, which are being discussed and which are being mapped and monitored at different levels, national and international levels. And IPCC is covering it at the international level, in which we are participating, we are contributing to the BUR report. Nowadays, from the past 3-4 years, biannual report is going from Ministry of Environment and Forest to UNFCCC, in which we are trying to map the greenhouse emission concentrations. And there are various sectors. They are noting down the emission content which are emanating from agriculture, from water, from ocean. Many sources of greenhouse emissions are being captured, and we are contributing to the international reports as well. Now here, what are the remedies? As my lecture says, issues and remedies. Adaptation and mitigation. These are the two terms. I am not going more into this detail. Yeah. So now the fourth assessment report of IPCC, which came in the year 2014, it talks that there is a, again, what I said, it is depicted here. There is an increase in concentration of carbon dioxide in the past 100 years. Atmosphere has warmed by 1 degree centigrade, and it is witnessed by severe extreme weather events, and there is a sea level rise. Now coming to India. India, these are the observed changes and these are the projective changes. This is the outcome of a latest report just released this year, just last month only. So you see our country, we have got increase, the temperature risen by 0.7 degree, which is less than the average global temperature all across the world. Still, we are having 0.7. And all these statistics, I think I will just skip it. If somebody wants, I will share this with them. So here again, what I said, it is talking about that. But only one thing I want to highlight here, that over Indo-Gangetic plains and Western Ghats, the monsoon precipitation that has declined. So the report says that. And again, the sea level rise is also going to be accelerated. And projection says that it's going to be too high in the time to come. So these are the 2 points which I want to say. Now, what are the greenhouse gases in agriculture sector? Only one slide I'm showing to them, to all of you, which is the latest one captured from MOEF from their report, BUR report, which I mentioned just now. So here, agriculture students can see that 16% of emission is contributed from the total emission of 2607 million ton CO2 equivalent from agriculture. So it is the second largest. After fossil fuel, agriculture is the second largest emitter. And then what are the different subsectors, areas which are contributing to agriculture? So here you can see that agriculture soil, again for the soil students, you can take it as a topic of your research in your PhD or MSc if you want to study in details about for Muzaffarnagar soil. So much of work has already been done by Dr. Kalra, Dr. Puruthi, Dr. Giriraj, and Dr. Malik as well. So you can think of taking it as a topic of your research. And rice field crop residue burning is another latest issue, which now is being discussed all across the meetings and sectors. Government is trying to know more what is happening with regard to crop residue burning and how this emission can be reduced. So this is also another important topic. Manure management, of course, and enteric fermentation. So these are some of the topics I wanted to share with all of you to consider as your future research. Yeah. Now coming to the impact of climate change on agriculture. So this is again, I am not going into detail, only through this flow chart I would like to tell you, and I am very sure all of you might be knowing. So here is telling that, as I said, that there are increased frequency of weather extremes, storms, floods, and droughts. These are the extreme weather events which are affecting our agriculture sector. So not only agriculture, even all across the overall ecosystem is getting affected by these extreme weather events. There is loss of biodiversity in fragile environment, forests are getting degraded, loss of fertile coastal lands caused by rising of sea level. These are all like like impact of one sector on the other. So you will see it like that. All factors are getting affected, getting impacted by each other. Then there are longer growing seasons in cool areas. So when you go to Himalayan side, no, upside, that is again another like topic of another lecture. There we find that there is more warming as compared to the plains. And the growing seasons are getting longer in cool areas because of climate change. So that is also another issue of concern. Increase in incidence of pest and vector-borne diseases and more predictable farming conditions in tropical areas. Already we know, like it's quite unpredicted in tropical areas. When we talk about aquatic species, so there is also impact in terms of distribution, and they are getting extinct and they are dying also due to high oceanic temperature. So I can say that long-term fluctuations in weather pattern could have extreme impacts on agriculture production, slashing crop yields and forcing farmers to adapt or adopt new agricultural practices in response to their respective altered conditions. And nowadays we talk about local specific solutions. So that also you have to keep in mind while drawing any strategy. So these are some of the impacts already I have discussed. Yeah. So IPCC 2018 report talks about the extreme weather events, which can be in terms of cyclone. You can see the frequencies increasing like anything. Heavy rains, heat wave, flood, drought. So these are the main extreme events which have been identified by them. So how they are going to affect when we talk about water. So already Dr. Kalra had very nicely mentioned about various issues, various problems in water management, what we are facing, our country is facing. But here, one thing that in some areas we may find water scarcity due to climate change. That is also another issue of concern. Some areas are having extreme drought conditions, and some areas are having excess water. Flooding is happening. Like nowadays, we have seen Assam and Bihar, like there's so much of flood which is so difficult to control, Maharashtra. So there is no answer to all these kind of situations, why all this is happening, but it is happening. And that is now getting contributed to the climate change. And you can understand the impact of this kind of unpredictable nature of these events, not only on agriculture, but in other sectors as well. But here these pics shows that if there is a drought condition or scarcity of water, it is going to impact crop. And if there is a flooding, again, it's going to damage life like anything. Yeah, next one. Now coming to soil degradation, because I showed some of these issues are there. So I just want to show you that how it will look like. So with increased intensity of rainfall and slopy land, soil erosion may be intensified. So here, these are two examples, and there are going to be many more examples in terms of soil degradation. Yeah. So broadly, the impact of climate change on agriculture. So I think I have discussed all these issues while my talk, which talks about extreme weather event, the decrease in freshwater resources, scarcity in arable areas, changes in rainfall patterns, shortage for irrigation, temperature increase and water scarcity affecting plant and animal physiology and productivity, sea level rise, changes in water flow, changes in plant, livestock, fish diseases. In agriculture, this again is an important sector, which are again getting impacted due to all this, and fisheries and aquaculture. And acidification of ocean is another issue of research with extinction in fish species, which also I mentioned in my previous thing. Now coming to the outcome of a report. This is the IPCC AR5 findings. And specifically, I have picked up with regard to agriculture, what are the implications seen at the international level. Here you can see that impact is going to be severe in many regions of the world. Already it has been understood. Evidence confirmed, scientific evidence, because as I said that all the countries are contributing with regard to their nation. that the effect of carbon dioxide and elevated ozone on crop yield. The evidences are there. And if global temperature increase of 4 degrees centigrade or more above late 20th century levels, and if it is combined with increasing food demand, it will pose extreme risk to the food security globally and then regionally. Nowadays, we talk about regional issues, how to solve it. Climate trends are affecting the abundance and distribution of harvested species, which already I mentioned, and CO2 concentrations, of course. Here you can see for major crops, wheat, rice, and maize in tropical and temperate regions. So these two I want to highlight. Tropical and temperate region where India is representing. Climate change without adaptation will negatively impact production for local temperature increase of 2 degrees centigrade. So we need to go for adaptation and mitigation processes at the earliest possible. Now, another figure I would like to share with all of you. Here it is telling about the projected decrease in crop yield under global climate change scenarios over the 21st century. This is again a projection. You can see the time windows from 2010 to 2110. Almost for next 100 years, it is giving the projection. And here only you focus on these part. Yellow bars are towards decrease in yield, and blue shades are towards increase in yield. So you can see very well. It is constantly showing increase, enhancement in the yield reduction. I will put it up like that. So this is again a cause of worry all across the world. And here it says after 2050, the risk of more severe impacts may increase. Risk to food security are greater in lower altitude areas, that is tropics. So this is one of the outcome of this IPCC report. Here only one thing I wanted to highlight, that out of these crops which are of importance, you can see the impact of recent climate change trends. It's showing trends. You can see which crop is going towards negative and which is going towards positive. So here, wheat and maize, you can see these are more towards declining side. And soya bean and rice, we can say that towards little increase in the, if we consider the trend in climate and impact on the 4 major crops. So now through these sections of my talk, you have understood what is agriculture scenario, how it is getting impacted, and what are the studies all across the world which talks about the projections and what are the issues of concern. Now I will be touching a little bit upon the adaptation and the solution part. That is the final part of my talk. So here I want to show to all of you the vulnerability. Indian agriculture, how much it is vulnerable to climate change. Here you can see these are the outcomes from 2 different studies. This study was conducted by IRI team as a part of the Center of Excellence of DST, my department. We have I will tell at the end, or Dr. Akhilesh Gupta will tell about what activities we are doing in Department of Science and Technology with regard to climate change missions. But this is one of the outcome of our work, which was conducted by IRI team, that the country is quite vulnerable with regard to the climate change impact on agriculture. So this is from 60 to 2010. And here the red part talks about the high vulnerable zones. And this mustard color, this is again high, very high to high. So you can see wherever you're finding red, it is highly vulnerable regions to the agriculture when we think about climate change scenarios. And this is the study conducted by NICRA, which was done in 2013. This is our latest study. Here also you see more or less it is the same region. Here the index shows
that this pinkish part is very high and pastel color is high. So the regions are almost same. And these are again a cause of worry because the major part of our country is towards the highly vulnerable zone, and the projection tells it is going to remain so in the next century as well. Now, as per the global report prediction, a loss of 10 to 40% in crop productivity is estimated. So again, I'm linking with the previous slide. So I'm not saying all this because already I have covered, but you can just think 10 to 40% in crop productivity decline. So where are we going to head? Our population is getting increasing. And in the next century, we can expect how much is going to be the population rise. But at the same time, the productivity is decreasing. So what to do? That is again an issue of concern. And this is the cropped areas affected. I am skipping this one. So now let us link this study with the economic part, with pricing part, because some of the students might be from agriculture economic sectors, themes as well, especially the international friends. So here, again, these crops, maize, rice, and wheat, and other crops. If you see the impact of climate change on crop productivity and the price, growth rate is going to decrease. In maize, you see, with 12% of growth rate decrease, price may increase to 90%. By 2030, 9 out of 10 major crops will experience reduced growth rate and prices will increase due to climate change. So this is again an issue of concern. Similarly, you can see in all the crops. Rice 23% decrease, wheat 13% decrease, other crops 8% decrease. And the prices are also ranging from 75 to 90%. They are going to increase. So again, these are very, very alarming situations. So this is from CIMMYT. Now, the latest data I couldn't get, but I'm very sure it might be again alarming if we go into the current statistic. Now, this is one overall slide which talks about the Indian agriculture and what kind of projected climate impact on like Indian agriculture. The agriculture loss over $7 billion is estimated for 2030, which may affect the lives of 10% of the population. Decrease in yield of crops as temperature increase in different parts of India. So again, the projection in temperature increase is by different simulations, which again are ranging from I think 1.5 degree to 4 point, or I think 6 degree also in those simulations are simulation. So some of the outcomes are like this. 1 degree centigrade increase in temperature will decrease the wheat production by 6 million tons. That is one projection. Crop yield in rice and wheat production has already declined in Indo-Gangetic basin. Monsoon sorghum grain yield is projected to decline and it will worsen by 2050 and 80. Quality of various crops such as cotton, fruit, vegetables, tea, coffee, aromatic and medicinal plants, they are going to have very poor quality in the time to come. Production of apple in Himachal Pradesh has steadily increased, but the productivity has declined. This is again contributed to the shift of apple belt due to the warmer climate change, which I said that in Himalayan region, they are witnessing more warmer environment as compared to the lower zones. Apple cultivation belt already I mentioned. Nutritional quality of cereals and pulses may also decline subsequently, affecting the nutritional security of several developing countries where cereals are the primary diet. So these are some of the outcomes from this report. Now, who are the most affected people? We are still at a very, very fortunate position that despite all these impacts, we are able to just go with the required things. We can manage. But poor people are especially the vulnerable ones. And but like they are contributing to the most, but they are the most vulnerable. That is a cause of worry. So they have limited adaptive capacities as well. They don't know how to adapt to the situation. We have to tell them easy to adopt technologies and measures and advisories so that whatever they are putting into their farming options, they are getting the return for their livelihood. So they need to be more dependent on climate sensitive resources such as local water, food supplies. So there are many more things. I think agriculture economic students will add on to this aspect as well. So what are the adaptation and mitigations which can be taken up immediately by them? So these are certain things. There are many institutions who are working, not only the Ministry of Agriculture, NSRA, and I came across many other institutions who are working into the development of various techniques and like remedies for adaptation and mitigation to climate change. So one such is adaptation. Crop has to be more resilient too. We need to go for heat resistant variety, drought resistant variety, flood resistant variety, salinity aspect, and pest and disease. So these are some of the areas which requires immediate attention. And already these varieties have been developed by many organizations. So we have to go for these varieties. And mitigation talks about efficient water use mechanism, fertilizer use, and energy use. These are the broad three things which comes under mitigation. And there are various techniques which I will just tell quickly, just to give you a feel. This is another study conducted by Niti Aayog recently in the year 2017. So being a representative from Government of India, I just thought of sharing some of the important reports and outcomes with the gathering. Here, they have conducted a study to understand the base level and target for development initiatives to double the farmers' income. Because our main goal is how farmers are getting benefited with all this improved like agriculture productivity and all these scenarios in the sustainable manner. So what they have said, it's a very thick report, but the crux of it, I will just share with you. It is talking about certain development initiatives. So in these initiatives, agriculture productivity is the main fora which they have picked up. It's the main domain. And in agriculture productivity, they are talking about better technology and varieties and increased use of, here you can see, increased use of good quality seeds, efficient fertilizers, irrigation measures, electricity, area under more than one crop. So they are talking about crop diversification, monocropping, and many other things. Area under fruits and vegetables, area under high yielding varieties. So if somebody wants, you can refer this report. No, this is the report. I have only picked up 2-3 things from there, but there are many things which you may get in that report. So they have compared with the base level and year. These are the years and these are target for next 5 years. So here you can very well relate that wherever there is a need to go for a sustainable measure, if we want to go for the sustainable development, considering agriculture productivity as the main theme. Another thing which is mentioned in that is that actually I happened to participate in one of the sessions conducted by National Agricultural Research System, NARS. And they were sharing their technologies which they have like produced for agriculture sustainability. Likewise, there are many ICR institutes, SAU universities, and institutions like DST where the missions are being implemented in which agriculture is one of the main focus area. So in our mission also various technologies are getting devised and which are getting implemented in experimental mode. So despite doing all that, what are the issues which are not making us reach to the expected level of productivity increase which is expected? So these are some of the issues. Despite the plethora of technologies developed, the adaptation rate is low in many states. So it is again a state level issue. Technologies are available, but state has to take a lead. But in some of the states, we have to create that awareness that these kind of techniques are available and all need to join hands together in terms of utilizing these things. Adoption of technologies for natural resource management and then recommendations related to farmers who are working in isolation. So these are again broader issues I'm just touching upon because I found these are very important when we are talking about agriculture productivity. So it is just to give you a glimpse of all the technologies for adaptation. So you can see, as I mentioned, for water management, these are the adaptation techniques which are right now available. Water saving dry systems, rainwater harvesting, farm ponds, micro irrigation. Similarly, for soil nutrient management. So these two in my earlier talks also, you mentioned about these issues. So for soil nutrient management, conservation, agriculture, soil health card. This is again another thing which is being taken up under ICRA, and even this agriculture mission of climate change also is working on this. Neem coated urea, that is another good thing. Foliar nutrition, biochar, residue recycling, biogas. Likewise, you may find in crop based diversification, fishery, farm mechanization, livestock and poultry, all areas there are plenty of adaptation technologies available. One has to move ahead in terms of implementing as per their requirement and access. And here, agro advisory and decision support system, they play a very important role in technology dissemination. So more and more awareness creation is required. And we at Department of Science and Technology, we have set up 25 state climate change cells in many states of our country who are working very actively in collecting the information with regard to impact of climate change on various sectors, agriculture one among those sectors. If anything required, we can also brought those centers together, and we can really look into the task together. So this was the another point which I want to share again from the Niti Aayog report. They are talking about policies and reforms. So I really find it very nice when they are talking about national agricultural policies, which has already set up
Hello.
many clear objectives, which will give a agricultural growth rate of 4% per annum. If we confine to
सर
these
मैं
kind
तो
of
जा रहा हूँ घर
sustainable issues, no?
मैं
Agricultural Produce
तो
Market
घर कोई नहीं जा
Committee,
रहा है
which was also set up, and there are many
हाँ
other laws.
तो
I was
मैं
more bothered about coordination and involvement of states, which is made effective with the role of Ministry of Agriculture, Cooperation and Farmers Welfare at the center and government of respective states and UTs. And now many more ministries and departments are also working together in coordinating and providing research-based results for better implementation. Now this is last part of my talk. Here I felt like giving a feel of what kind of national missions are on board with regard to our country. So as I mentioned, there are 8 national missions which were launched by Prime Minister Council in the year 2009 and which are being led by different ministries. So 2 specific missions which are dealing with agriculture, sustainable agriculture is National Mission on Sustainable Agriculture, which is being implemented by Department of Agriculture, Ministry of Agriculture, ICR. And another one is National Mission on Sustaining Himalayan Ecosystem, which is led by us, Department of Science and Technology. In fact, we are implementing 2 missions. Another one is National Mission on Sustaining, National Mission on the Development of Strategic Knowledge on Climate Change, in which agriculture, along with other sectors, we are working on that. So this is the aim. Already, I think being agricultural scientists, all of you might be knowing, I will not go into details. Already I have mentioned in my talk. Yeah, NICRA, another big exercise. Already all of you know that 121 Indian districts have already been covered towards technological interventions. And I showed you that vulnerability mapping also, which they have done for the next century. Now this is NMC, this is DST's mission, which we are doing at Department of Science and Technology. This is the only location specific mission for Himalayan area, which is being implemented by us from the past 7-8 years. And 6 thematic task forces have been developed here. They have been set up. And one specialized task force is on Himalayan agriculture. So this task force is being implemented by ICAR, and they are working on collection of data on pan-Himalayan basis. These are the 3 regions which already they have taken: cold, arid Himalaya at Kazri, lower and middle Himalayas, IISWC, the Soil and Water Conservation Institute, and northeastern Himalayas. They are being covered by northeastern hill region. So this is one of the most promising task force in which various good technological interventions on pilot scale have been devised, and they are implementing by all the 12 Himalayan states, which are leading towards the increase in crop agriculture productivity in a sustainable manner. This is again, I'm not going into it. I already mentioned. But here only one thing I want to highlight, which I told in my talk, that when we are talking about resource management for a particular landscape, we need to go for human resource development. We need to go for capacity building. All the youngsters, researchers, they must be trained in devising and implementing new technologies, and also going for latest research tools, no, which will be helpful for developing farmer-centric approach, and further it may lead to the policy decisions as well. And of course, it has to be at village level. So this is the overall approach which we want to adopt, and this is again part of issues and concerns of the communities. Already, I think you all might be knowing about climate resilient villages. So this structure has already been adopted, and work is on, in which various sectors are related to weather, water, crop, nutrient, carbon, and then institutional, which I said about capacity building and community-based approach. Climate smart agriculture is another buzzword which all of you might be knowing. It talks about various elements such as management of farms, crops, livestock, aquaculture, fishery, which I spoke in the beginning, so I'm ending with that only. So these are all the sectors which are required to be seen holistically if we want to go for a sustainable approach to enhance the agriculture productivity, and it has to be at ecosystem based approach with landscape management tools to conserve ecosystem services, which can lead to the efficient resources and better resilience for the community. And of course, we need to provide better services for farmers and land managers to create an environment which is conducive to the implementation of the required changes, considering the climate change issues and its impact on agriculture. Some of the states have already implementing, they are in the process. So this is one example I'm showing to you. So now at the end, I would like to summarize that agriculture causes climate change and suffers from the consequences. All of us are feeling the brunt of it. Adaptation options are available, and we need to go for those options, and also for various management practices which are shared by various organizations, research organizations, to the stakeholders. Mitigation is quite possible, but there is a need to implement these efforts. More efforts are towards adaptation, but mitigation options also need to be adopted. We need to develop an integrated land use policy and crop planning approach. Capacity building is very important in the current scenario. We need to go for strengthening the weather services, ICT, and climate literacy, and awareness of poor farmers and local people, local community. And here I would like to say that Department of Science and Technology is in the process of formulating a new science policy, which Dr. Akhilesh Gupta, I hope he has joined us by now. He is spearheading that important activity. We would love to hear from him, in which climate is another major theme out of 6 tracks which he has identified. So he is working very strongly to bring climate issues into the S&T policy. So this is very important thing, and our department is working on it so that all can join hands. And then linking climate management with market and development processes. This is what is the requirement. So thank you very much for sparing time. I hope my talk was helpful to the students and even to others. Thank you.
Thank you, Nisha, for sharing your immense experience and thoughts with us and giving us your time. Thank you very much. Now, I would like to introduce our chief guest, Dr. A.K. Gupta, former secretary of UGC and presently senior advisor, scientist G, head STIP 2020 Secretariat, Action Enabler, Splice Division and Climate Change Program, Chief Vigilance Officer, Department of Science and Technology, Government of India, New Delhi. Dr. Gupta is well-known eminent scientist with specialization on meteorology, medium-range weather forecast. Dr. Gupta is currently leading Science, Technology and Innovation Policy STIP 2020 formulation process, which has been jointly launched by Office of PSA and Department of Science and Technology. Now, I would like to invite Dr. Gupta to express his valuable views.
Thank
Dr.
you, Dr. Giriraj Singh. Very good afternoon to everybody. I am very delighted to see my friend, Dr. Naveen Kalra, also some of the known faces, Dr. Naresh Kumar, Dr. Kruti, Harendra Sirohi, Dr. KP Singh, and of course my colleague, Dr. Nisha. First of all, let me compliment you for organizing this very important international webinar on meeting the challenges of declining soil production and rapidly changing climate for sustainable agriculture. This is a very important topic. I think I was listening to Dr. Nisha and also part of Dr. Kruti's talk. So I'm not an expert in this area, so I would be limiting my, I would say, intervention to some of the issues which are very important in the sense, in the context of the topic that has been chosen. Uh, I think all of you well aware that our annual food grain production has been increasing since the independence, from 50 million ton to now 290 million ton. And with time, we are in fact making effort to increase the production, and of course, link with that is the productivity, so that productivity is also increasing. Although the total arable land has decreased over the time. That shows that India has been focusing on productivity right from the independence time. Now, this is like, it's very interesting. I know this figure because there was a report on the crop production. I had myself authored it. That on an average, uh, India's consumption, per capita consumption per day, is roughly around 450 gram as against 850 gram of China and more than 2000 gram of US. So we have been very conservative in terms of consumption. Now, if you calculate the total food grain required with this consumption pattern, it comes to 220 million tons, which means we still have a lot of, buffer for export as well as for storage. Now, what is the issue is now with the kind of, there are two challenges coming here. One challenge is that past several years, our production is stagnant at that level. 280 to 290 is hovering around that figure. Whereas the population is, the growth of population is increasing. That is so. So there is a dichotomy between the growth of population and the growth of productivity or total production. This dichotomy is an interesting thing. Now, over and above comes the climate change. So, climate change, there are mainly three things that climate change is going to impact. One is, of course, temperature. Dr. Nisha has elaborately mentioned what kind of crops which are going to be. Mainly, Rabi crops are going to be majorly impacted by temperature. Then comes extreme rainfall, and I'll tell you there are some new findings in the extreme weather, extreme rainfall, and I did not find that mentioned in Dr. Nisha's presentation, but I will give you latest development in this area. So the extreme weather events, especially temperature and rainfall, are the two major causes which are going to impact climate in the crop production and productivity. Third thing is, of course, the pest and disease. Now, there are many areas which are not having certain kind of pests, going to have pests in the future. And it comes mainly the combination of rainfall, which is causing the humidity and the temperature combination. The change of temperature regime is very interesting. Now, the extreme heat conditions is spreading over the entire country. Latest data shows that heat wave conditions now prevail on the every part of the country, almost every part of the country, which was not the case earlier. This is changing the whole scenario. The big change which I mentioned just now is coming in terms of changing rainfall pattern. Heavy and very heavy rainfall rainfall incidences are on rise. Moderate and low rainfall events are on decline. Now, this is creating a big problem for the agriculture because the average rainfall for the month may be same, but when you have more number of heavy rainfall, less number of moderate and this small rainfall, your entire pattern will change because number of rainy days will decrease, and more importantly, when a weak rainfall falls on a day, you have more runoff, and because of runoff, you have more flooding, but also importantly that groundwater does not get recharged. So and then this will have Godima. Some people think arborities have only impact on the rainfed. No, it will have also the impact on the on the irrigated areas, because the irrigated area less water is available in the ground and underground, and in the rain-fed area you have more rain going as runoff than going down for the soil. So soil moisture will also get impacted because of the. So this is a cause of concern that which is going to come, and I think I will not go into my detail. Now let me give a figure that uh, we have an issue. I think the world over the issue is there. I'll come back to the same issue. The total production is about 290 million ton, but you have the poverty line, really 6.7% of India is below poverty line. Now, the figure which I have given you, 450 gram per day per person, is an average. But the poverty line, which is below people below poverty line, they have much lesser availability of food today. So that being the case, when we are going to have increase in temperature, with increase in the overall GHG in the world, we will face consequences, and therefore these need to be addressed in a more coordinated fashion. Now, soil part is very important, as I think, since your topic of discussion is the declining soil productivity. Therefore, there comes the concern, and that concern comes from all consideration of climate change. I mean, that includes more very interesting pattern that is observed. And I want to put it here because there, I'm sure many of you may be knowing that entire India is experiencing increase in the extreme rainfall, and followed by that the flooding. But interesting part is that these floods are mostly short-lived floods, short duration floods, which is caused by the heavy rainfall. The large scale floods are actually on decline. So the floods caused by the riverine flooding actually is on decline. Good news, but the bad news is that we have the short-lived flood increasing at almost everywhere. Now, this is generally in the, I mean, you see, a word over picture is that soil fertility is decreasing everywhere, almost everywhere. There is a soil fertility is falling. In fact, a large number of areas in the world are actually, showing decline in terms of, in fact, they are nearly, in fact, I would say, uh, I mean, there is a report of the Global Assessment of Land Degradation and Improvement called GLADA. GLADA report says that 1/4 of the land area around the globe has become degraded. So nearly 1/4 of the land has become degraded. With the kind of pattern that is projected in future, this is going to further deteriorate. Now, so, and as I said, when you have the climate change impact where the floods are increasing because of heavy rainfall and short-lived rainfall, at the same time, drought is also increasing because rainfall is taking place in some area, other area remains dry. So the drought and floods are the two extreme. So I am a meteorologist, so I always used to make fun on my people. Always the meteorologists they will say, "Sir, the rainfall is normal because somewhere flood, somewhere drought. If you add them divided by two, it is all normal." But I think that's a total a kind of misconception and a totally wrong representation of the climate impact. So therefore, what is the ultimate way of coming out of this? The only way that these issues can be sorted out, can be addressed, is through having a smart agriculture system, which means, what do we mean? Smart agriculture means that we had to build resilience towards climate change. And so drought resilient and flood resilient varieties are the answers for such kind of extreme that are impacting. Of course, they all have limitations, I understand, but that is the way only thing that can be addressed. Of course, there is a lot of research. We have funded a big program in ICRISET where the issues related to pest and disease are being addressed. And they are very, very, again, so just like drought and flood variant, resistant varieties are to be developed. In the same way, I think pest and disease resilient varieties also need to be developed. How much we will be successful, we don't know, but I think the agriculture scientists at large, they had this challenge of developing such varieties for the country. We have no option but to make agriculture sustainable. So let me give a figure that by 2050, we will be something like 1.5, 1.6 billion in population. We need a production of 350 to 370 million tons annually. As I said, right now we are 280 or 290 between that. How are we going to meet this challenge? That is a big issue that agriculture scientists need to bring. Soil productivity also need to be maintained or made better. How we will do it? And despite all those challenges that come, how we are going to increase the productivity or increase the production, and low production is the way forward. A lot of work is being done, but I think a lot need to be done. So I would conclude by saying that we have a lot to do. In fact, we are becoming defaulter in some of our sustainable development goals. One of this is the food security issue. So, uh, in fact, the overall production world over is increasing marginally. So now, in fact, the total world production of food grain is something like uh, 800 plus million ton. So this is like, uh, but I think so much is needed to be done. Uh, I'm sorry, this figure is not for the overall. I think much more than this. So this is but there are so many things that are need to be addressed, and therefore the overall, I would say that the agriculture need to be made sustainable with several measures that need to be taken, including the ones I have mentioned, that is making agriculture more, I would say, smart in terms of creating resilience against the extremes of climate. So with that, I think I thank once again the Choduram College. In fact, I would say whenever I meet, or I'm meeting after a long time, both Naresh ji and Giraj after a very long time. But it refreshes my memory. In 2010, I came for the first time there and saw this college. So a lot of good work has been done there, and I am very happy that the Dr. Nisha is a student of that college, and so it's all very sweet memories, and I'm very happy that very delighted to see that conferences of this kind is being held. I would suggest that we organize more and more such kind of interaction. These days, the advantage of COVID is you don't have to do anything physically, so no cost to anybody. So you don't worry, and on DST side, whatever help you need, whatever support you need, we are always ready. But I think you don't need that kind of support right now in this thing. Please keep organizing such interaction. It will definitely benefit everybody, and more so the students who like to get more wisdom from the expert. Thank you very much.
चलो चलो स्टार्ट हो गया मीट हो गया
Thank you, sir. Thank you, Dr. Gupta ji, for providing us your time and sharing your valuable thoughts and knowledge with us. Thank you very much, sir. Thank you. Now, I would like to invite Dr. S.S. Suri for a vote of thanks. Thank you.
सर अनम्यूट कर लीजिए, म्यूट है।
आज की वेबिनार के जो हमारे मुख्य वक्ता हैं, स्पीकर हैं, बहुत आदरणीय हमारे डॉक्टर नवीन कार्ला जी, डॉक्टर निशा जी, डॉक्टर एन.के. परूथी, और हमारे साथ अभी डॉक्टर साहब ने साथ साथ ही जुड़ाया था डॉक्टर ए.के. गुप्ता जी, जो हमारे महाविद्यालय से अधिक प्रेम रखते हैं। मैं इन सभी का अपने महाविद्यालय की तरफ से, अपनी तरफ से
No voice.
डॉक्टर वॉइस नहीं आ रही, आवाज नहीं आ रही।
सर अब म्यूट हो गए हैं।
हेलो, आ रही है आवाज?
अब आई है।
विशेषकर मैं डॉक्टर नवीन कार्ला जी का विशेषकर अपने महाविद्यालय की तरफ से आभार व्यक्त करूंगा, क्योंकि पूरा कनाडा इस टाइम सोया हुआ है और वो हमारे पार्टिसिपेंट्स को कितनी अच्छी बात बता रहे हैं हेल्थ के बारे में, उन्हें कितना फिक्र है इस देश के बारे में, कि इसको जो चैलेंजिंग है, जो डेक्लाइन सॉइल के हैं, प्रोडक्टिव सॉइल हेल्थ के बारे में बताया। मैं पुनः इनका हृदय से, अपने महाविद्यालय की तरफ से, अपनी तरफ से हृदय से आभार व्यक्त करता हूँ। साथ साथ इसी के जो हमारे इस वेबिनार में जुड़े हुए सभी लोग हैं, नेशनल इंटरनेशनल जितने भी पार्टिसिपेंट हैं, उनका भी मैं हृदय से आभार व्यक्त करता हूँ कि उन्होंने सबने जुड़ के इस वेबिनार को बहुत अच्छा रूप दिया। इसके साथ साथ मैं अपने महाविद्यालय के एडवाइजर कमेटी, ऑर्गेनाइजिंग कमेटी, सभी मेंबर्स को भी बहुत बहुत धन्यवाद देता हूं और उनका साधुवाद करता हूं कि उन्होंने इस वेबिनार को बहुत अच्छे ढंग से अरेंज किया और बहुत अच्छे ढंग से रिप्रेजेंट किया। थैंक यू वेरी मच।